So, hello everyone. I'm waiting for some 4 to 5 minutes so that everyone can join. Then we will be starting this session. So, just let me know that whether my voice is fine or not. So, am I audible?
Yes, ma'am.
Okay. So, since now it's like 6:05, so we will be starting the session now. Hello everyone. My name is Imanshi Singh. I am a research scholar at Department of Mathematics, IIT Jodhpur, and currently I am pursuing my PhD in broad area of probability and statistics. And also, I am your TA for the course Foundations of our Software. Okay, so today, as we are like continuing with the live sessions, so it is the actually this is the live session number. So it is the 13th live session because we had yesterday also we had an extra live session. So that was all about the revision which we have done, and also we have discussed some of the exercises or some of the examples which basically in order to have a better understanding about the topic. So, so I hope you people see that lecture also, and all the examples are discussed there. Okay, so today this will be our last live session. Okay, so after this there will be no more live sessions, and I think there will be all the week 12 content has been will be so 12 content will be discussed today, and the after this the you I think have your examination. Then yeah, so this course will be ending then. So yeah, this was the whole live session schedule, and we have completed all the sessions, and we are discussing about this 12th live session, and 12th week lectures will be basically discussed today. Okay, so these are the important links. So this is a Google Meet link, and the second one is the YouTube link. So here I'm uploading all the videos of this all the recordings for this class on this YouTube channel. So you can get it from there. Apart from this, all the art scripts and the presentations, the Excel sheets and all those things which we have used uh, during this live session all have been uploaded on this Google Drive. Okay. So yeah, we will be starting the session now. So plan will be same as before. So we will be having a brief recap about the topics. Then I'll demonstrate some of the programs which I think that the demonstration is necessary. I will be demonstrating them in R. Then we will discuss some of the practice examples, and I encourage all of you to please answer the questions so that the session is like kind of interactive. Okay. Then if you have any doubt, then you may ask. Okay. So the syntax will be in blue. Okay, everywhere. These are the slides which I have included from day one. I'm including these slides. So how to download R and how to download R Studio. So you may like you may have the knowledge of how to download these softwares. Okay, so I hope now we will be discussing the topics or the topics which we have discussed already, so which they have been discussed already in the week 12 lectures or content. Okay, so if we talk about graphics, so which we have already learned about two graphs in the week 11 lectures, that is about the bar plot. And apart from bar plot, we also had an idea about how to draw a pie chart. Okay, so or sorry, scatter plot. Scatter plot and bar plot we have already studied. Pie chart today we will study. So, in the previous class or in the previous week level lectures, we have discussed about the bar plot for a single variable. Okay, now if I have in place of a single data vector, if I have a variable which is in matrix form, then how the bar plot will be like. So basically, if I have this x-axis and y-axis, and I have this bar plot. Okay, and if I want to subdivide them, okay, in this way, okay, where this is representing some particular value, and the this length is representing some particular thing, and this length is representing a particular quantity, or I can say a categorical variable. Then in that case, basically we are basically subdividing the whole bar plot corresponding to a particular column. Okay, so for example, if I have I have this table where I have this is the number here in the table. I am entering the number of accidents. So this is day 1, okay, this is day 2, and this is day 3. And if I want to find out that this is road 1, this is road 2, this is road 3, okay, and here I have some entries, some numeric entries, which basically shows that how many accidents happened on day 1 on road 1, day 1 on road 2, and day 1 on road 3. Then these values will be representing then that. So this data we'll just store in a matrix form, and then we just put that data here. Then we'll have a bar plot. Okay, so that bar plot, the this single bar is like basically divided into different parts. What these parts represents that, so here it is corresponding to road 1, okay, so which is basically the column. So it will represent that how many accidents happened on day 1, and this height cumulatively basically, so this height will represent how many accidents happened on day 1 plus day 2. And this whole thing will tell you about how many accidents have taken place in all 3 days. So total number of accidents it will tell. Similarly, R2 and similarly on R3, this can be represented. So I can just like show it to you in R. So just give me a minute. So yeah, so this is the code. So here I have given this matrix. So let me first show this matrix to you. So this is a matrix, MAT. Okay, here I'm saying that the columns are representing the road 1, road 2, road 3, road 4, and the rows are representing the day 1, day 2, day 3, day 4, day 5. Okay, so then if I want to plot it, so if I plot this matrix here I have written matrix I'm plotting, and also with that I have written names.arg, so which basically give the names to the on the x-axis, that what a single bar plot is representing. Okay, so that is day 1, day 2, day 3, day 4. Okay, so which are basically the columns, because we have 4 columns. That's sorry, yeah, that's why I've written 4. And then I have written the different colors which I want. That first on the first bar plot, the color of the first partition is red, the second partition is yellow, third partition is blue, green, then sky blue. Okay, so let me show it to you, so how it looks. So it looks like this. So basically this is day 1. So you can see here the red thing is representing that how many accidents happen on the road 1. Then the yellow thing, so this height till the yellow, this whole height is representing that how many accidents took place on day 1 on road 1 plus road 2. Then this is road 1 plus road 2 plus road 3, the height of till the blue bar. And similarly these bars are representing these things. So whenever we want to like partition or subdivide this bar plots, then we can do it by using this. So for that we are basically using the same command, that is bar plot, which we have used for a data vector. But here now in the argument we are using the matrix. Okay, then only we will be able to do this. Okay, so this bar plot thing is fine. Just confirm. Please just confirm. Is it fine? So I hope I'm audible to you. Okay, so is this fine? Is this bar plot when I'm taking in the argument, I'm taking the matrix format, then what is it representing? Is it fine? Then I'll move forward. Okay, so I kindly request you, please answer whatever I'm asking, because then I will be knowing that you people are there with me, and I am audible to you all. Okay, so okay, then I will be starting with the pie chart now. So basically, what pie chart means, that if I want to, again, I want a representation of a particular categorical data. So basically, since this is also been emphasized, that bar plots and pie charts both are mainly or majorly used for the categorical data. Okay, so when I have categorical data, for example, for gender data, I have like females and males data, and then in that case, I want to draw a pie chart. Then how the pie chart will be? The pie chart will be a circle which will basically partition into certain this kind of partition will be there, and where the each segment represents a category. Okay, so each segment will be representing a particular category. Okay, now size of the segment will depend upon the relative frequency, and it is determined by this frequency into 360-degree, the angle, this angle. Okay, and the for this we use this command pi table x. Okay, labels is equals to, so in the labels we will just give the names. So this will be the name of for this segment, for this segment, so label will give them name. And table x, so basically we are not taking the data vector as it is, we are taking table x, which basically we are taking the frequencies. Okay, and we are just putting that inside this pie, and we'll be able to create a pie chart. Okay, so let me show you this in this also in R, if I have it. So, okay, I'll take the same data, this, and I'll just store it to, and then I'll just show you how this pie chart looks like. So, I'm just writing pie. And I'm writing this data vector as it is. Okay, I've just not named it, so there is no issue with that. So this is the pie chart here for this data. So here we have data 2, 5, 6, 3. We have different digits. Okay. So on that basis, how many times 2 is appearing, how many times 3 is appearing, or in that way it is created. Okay. So here we can see that 23 and 2 is appearing like majority of the times, and 11 also, 9 also. So we can see that which number is appearing more times compared to the others. Sorry. So this is the pie, this is about the pie chart. Now if I have to, for example, combine certain graphs in a single fold, in a single, you can say that I have a I will create a plotting area, where in a single plotting area I will be having different plots. Now for that, what I have to do, so for example, I have a pie chart and I have a bar plot. Then I want to plot both of them, or also I have a scatter plot. Then I want to plot all of them in a single plotting area. Then for that, I have to use this command PAR MF row is equals to CPQ. So what this P and Q here, so basically this P and Q will create an array of P cross Q. So 2 cross 3 array or 3 cross 4 array. So basically it means that 3 cross 4 means that there are 3 rows and 4 columns. So three in each row there will be 3 figures, and each column there will be 4 figures. So it will be kind of a 3 cross 4 matrices of plots. Okay, so in that way this works. So when I will emphasize this, I will create an array of P cross Q, then I will give the different figures, and it will be plotted in a single plotting area. Okay, so I have done that also. So if I show you, so I will create a 2 cross 2 plotting area. So I'm just running it. So now it is created. Now I have these 3 vectors, and I am first of all plotting a bar plot. Then after that I'm plotting plot x comma y comma z, x comma z. So this is basically where the commands when we want to plot a, so, or let me, I will be discussing it afterwards. So let me just use the scatter plot. So this we have already done. So these are the scatter plot only. So now we have 4 plots and we have 2 cross 2 array. So then if I do this, then you can see that all the figures are here. So this is a bar plot. This is a scatter plot of x. This is a scatter plot for y data vector. This is a scatter plot for So here, this is, okay, sorry, here I've written X. So there should be Z. So again, I'm doing this. So yeah, this is a scatter plot for Z. So this is X, Y, Z, and this is a bar plot. Okay, so this way we can combine the different plots. Okay, different graphics in general, I can say. Okay, so so this is about the bar plot and the pie chart and how do we combine them. Now let us consider this histogram. So if I talk about histogram, so basically it is an idea when different groups, we are basically uh, categorizing a data into different groups. Okay, it can be like 4 groups, 5 groups, or 10 groups. So the whole data is categorized into different groups, and now for each group a single bar will be plotted. Okay, now for each category. So for example, if I have an example for height, okay, then if I'm taking height of the people, for example 200 people, then height can vary from, like, it can be for a child it can be like 2 foot 3 feet, then it is going up to 6 feet or 6.5 feet. So we can just make some groups, like how many people are there from height 2 feet to 3 feet, between 2 feet and 3 feet, how many people are there between 3 feet and 5 feet, how many are there between 5 feet and 6 feet. So such kind of groups we can do, and we can plot those by using this histogram. Okay, now here the so this is like the main difference between this histogram and bar plot is like, so for bar plot I'm majorly talking about the categorical data, and categorical data will be plotted through the bar plot. However, a continuous data, for example this height, weight, so these are the continuous data, then for that we just use this histogram. Okay, and there are also, if I'm plotting an histogram, so the height of a particular so if I have this for example this is a histogram. Okay, this is a histogram, for example. So I have grouped these values as a single category, and I have made this histogram. So this basically means that this height, for example, this is 7. So this is basically showing that how many values are between this interval. Okay, so how many values in the data are there which are in between these intervals will be shown by this, the height of the histogram. However, this is basically the frequency sense. If we talk about the bar plot, similarly we have done for the bar plot. So this was the frequency. However, if I take frequency here, I have used this FREQ to be true. So this implies that the height will be representing the frequency. However, if I write FREQ to be false, then in that case, this will be the uh, relative frequency in a loose sense. So it will not be exactly relative frequency, because here we have this continuous data. So we have the concept of density for that. However, in a loose sense, I can say this will be the, in place of 7, it will be the relative frequency. Okay. And also for this histogram, if I'm talking about this width, so they may not be equal. They may vary. Okay. So this is not necessary that these widths are equal for a this histogram. So sorry, here it will be histogram. Okay. So this is about the histogram. Then we talk about the scatter plot. So we previously talked about this scatter plot. Like I have a single data vector and I am plotting it. So this will create a scatter plot, the way which I have recently created. Apart from this, if I have two data vectors, okay, for bivariate, I can say a scatter plot. Then I'll just write plot x comma y type is equals to p. So type is equals to p means that the points will be like this. Okay, points will be like these circles. So wherever the points are, so if I want to plot two bivariate data, or I can say two data vectors, then I can use this command same, but here in the argument I will be writing two data vectors. However, I cannot do that for three data vectors. This is only limited to two data vectors only. Apart from that, we cannot do, like I cannot take x, y, z. So that is not possible for this. Okay. So this is for the bivariate data scatter plot. Apart from this, if I have a scatter plot, so I have two scatter plots. I want to construct a matrix of scatter plots. Okay, then to construct matrix of scatter plots, this pairs command is used. So pairs c bind x comma y. Okay, so here x and y are two data vectors. Okay, then I can do, now here I can take three data vectors also, then it will be a 3 cross 3 matrix. If I have two data vectors, then it will be a 2 cross 2 matrix. So here it will be like a scatter plot between x, scatter plot between y. So this will, there will be nothing here, nothing here. However, here it will be scatter plot will between x, y. Here it will be like yx, so it will be like same. Okay, if there are three data vectors, then scatter plot will be like this 3 cross 3 kind of a matrix, where at the diagonal we will be having scatter plot xy. Here we will be having, sorry, xz, then here it will be, we will be having xy, and this, here we will be having xx. In that sense, the scatter plot will be the, I will be showing these commands to you in the upcoming examples. Okay, so just tell me that these things are fine, then I will be starting the practice questions. Is there is there any confusion? These all things I think sir has also discussed. Okay, I'm just giving you a brief recap. So are these fine? Should I move forward? Any doubt, anything? So is it fine, or any doubt? Any person, if any person have any doubt, then please ask. Or if it is fine, then please tell me that it is fine. Okay. So now I'm expecting you to answer. Okay, I'm just going towards this question, and please answer the things which I'm asking. Okay, so here in this question, first, a data of 20 people of their preferred mode of transport to work is collected. Okay, that is like they can. So there is a like 20 people were asked about that which is the mode of transport they prefer to work to go to work. Okay, by which they prefer to go to work. So that is car, bus, train, a bike, or by like walking. So this data was created, so this data was collected, so this is given here in the table. So there are some car, some train, some bike, and some, so this kind of data is there. So there is number of times walk is appearing, number of times car is appearing. So this, that's that we can take by using this table command. So we can get that how many cars are there, how many buses are there by using that. So basically that is not my concern here. So what I am asking here, so this is a command, so this is an R command. So here we are using this bar plot. Okay, bar plot, and here I have written some see this star 1 star, I have written star 2 star, star 3 star. So this I have written. So here I want you to ask that, I want you to answer that what should become here in place of 1, 2, 3, 4, 5, so that we can get this kind of bar plot. I hope this bar plot is visible. So let me zoom it. So just tell me what should be in place of star 1 star, so that I can get this kind of bar plot. So what should be here in place of, so this is a command I will write in R. So what should I write here in place of 1 star 1? And I want to get this kind of bar plot. Just tell me. So transport is basically the variable in which I am storing the whole data. So this data is, so this data is stored in a variable called transport. So transport is a variable in R. Okay. Now tell that what should be there in place of star 1 star. So what should be there? When I use bar plot, then what should I use here in place of star one star to get the bar plot like this? Any idea? Anyone? Okay, so if there are no answers, then I will be writing that. So here, see here in the histogram, you can see that in the y-axis, you can see that it is 0, 1, 2, 3, 4, 5, 6, 7. So this is this these are the basically absolute frequency, because relative frequency will always be between 0 and 1. So that will not be exceeding 1. So for that, so this is basically the frequency. So if this is the frequencies, then for that to come here in the bar plot, we use here table, because bar plot we are basically plotting the frequencies only in the form of these bar. The height will basically represent the frequency of a particular category. So here in place of this it will be table. So is it fine? Is it convincing? You people have studied this thing. So in place of star one star, we should write table transport. So is it fine? Just answer this. Yeah. Now similarly, just tell me that what should be in the place of star two star. So star two star is equals to transport preferences. So basically transport preferences is the title of this histogram. Sorry, not the histogram, it is the bar plot. So this is the title of the bar plot. So what should be here in place of star two star? So what we write in the syntax? When I want to give a title to my bar plot, then what should I write? How should I write it in the syntax? So what should be here? So, okay, I will give the answers for this question. Now, similar type of question I have taken again also by using the histogram, and then I'm just expecting you to answer that. Okay. So here, when I want to give a heading or a title to my histogram, then for that I use main. Okay, main. So in place of star to star, main will come. So main is equals to this thing, transport preferences. Okay. Now I want this star three star is equals to mode of transport. So what is mode of transport? Mode of transport is the x-axis thing. The label at the x-axis. So that is the mode of transport. So for that I write x lab. Okay. So I write x lab and y lab for labeling the x-axis and y-axis. Yeah, it is x lab. Correct. So now, okay, fine. Now, in the star four star, I have written COL is equals to star four star. So what will be star four star? So COL, you may get the idea that it is we are talking about the colors. Okay. Now here you can see this is red color, this is blue color, this is green color, this is yellow color, and this is orange color. Okay. No, you can write COL is equals to 5. So what does that mean? Color in place of colors, you should write 5. You should write the 5 colors which you want to display here in the bar plot. So you should write that. Okay. So that will be what? So you should write C. So first color is red. So you will write red. Second, you want blue. So you will write blue. Third, you want green. So it will be green. Then you want yellow. Okay. Then orange. Fine. Now just tell me about the legend. what does legend represent? So here in the right hand corner, the top right corner, if you see, so there is a box. So where it is showing that what does this red represent, what does this blue represent, what does green, yellow, and orange represents. So this thing which we basically call as legend. So in place of legend, so in place of star, 5 star, what should I write? So whatever I have written here in the same order, we will write it there. Okay, so I write car, bike, bus, train, walk. So I'll write here that same thing. So car, bike, bus, train. Fine. Okay, now can you spot something which is missing here? So something which we have not emphasized and which is there present in this bar plot. So wait a minute. Something which we have missed, but it is present in the bar plot. Is there anything? Is there anything which we have missed, but it is present there in the bar plot? So see, here in the command, you see that we have given the transport preferences, means we have given the title. Okay, then we have given mode of transport in the X label, so that is given. Okay, here we have given ylab to be number of people, so here it is given number of people is given. Colors are given, so red, blue, green, yellow, and this orange will be there. Legend is given, so this legend will be there. There is no problem. So only thing which is left, which is this CBBTW. So by default, these are the names which basically we assign. So by default, they will be the names of the category which is present in the data already. But here I've changed that name. So the names of the categories were like car, train, bus. So by default, if I'm not emphasizing anything, then by default it should be car, bus, bike. So car, bike, bus, train, walk. So it should be like that. But here it is not by default because the CBBTW will not come by default. So here the thing which is missing is the names of these arguments. Okay. Now for that, anyone can tell me that what is the command we use in order to name these categories? Can anyone tell me that what is the command which we use in order to name the categories the way we want? See the value on the y-axis, which they are coming like 0, 1, 2, 3, 4. So they will come by themselves only because they are basically representing the frequencies. And here we have written table transport. So that is like, okay, fine. But on the x-axis, this thing you have like written it correctly, that the value on the x-axis which we have written like CBBTW. So this is not coming by default. If I'm not emphasizing anything here, it should be the category of the what this category is, what this category is, so that should be that. But here we have not emphasized that. So what should be the command for that? So it will be like so for that we use argument, that is arg dot names. So we use this command in order to get that. So that is c, so it will be c, it will be b, it will be b, it will be t, and then w. Arg dot names, that will be used in order to get such kind of histogram. So we have missed that. Okay, so if we also include this also here in the code, then it will be like this. So let me show this to you. So it is not argument dot names, it is names dot rj. Sorry. So it is names dot arg. It is names dot arg. Okay. So here I have done this. So let me show it to you. Here I have written all the things included. Then see, this is the histogram. The same here we have CBB. And let me also show you if I do not emphasize this thing, names.arg, if I do not emphasize this. For example, let me not emphasize it. Then what will be the output? Just see. So see here in the x-axis it is coming like bike, bus, car, train, walk. So this is basically the categories which are present already in the data vector. So by default it is bike, bus, car, train, walk. But in here the figure I have given CBBTW. So for that you have to emphasize that what should be the names of the categories in the bar plot. Okay. So I hope this is fine. Is this fine or any doubt? Okay, then we'll move forward for the next one. So here again, I have a data of age of 20 people. So this is the age of 20 people. Okay, these are written in this table. Now, and I am storing this data of all the data in a data vector which is named as ages. Okay, so I'm storing this into a data vector ages named as ages. All the entries into this data vector ages. Okay. So here this is the R command. Okay, now hist is used, means we are plotting the histogram. Okay. Okay. So hist in the first argument of hist, it is star one star. So what it should be? In the first argument of the hist, what we write when we want to plot a histogram, and here it is a data vector which is named as ages. So I have stored all the values in ages. So what should be here in star one star? In place of star one star, what we should write? So in histogram, when we are discussing the bar plot, then in that case we write table in the table, and in the parenthesis we write the data vector. But in the histogram, it is a different thing. But we do not write this table or something like that. We just directly write the name of the data vector. So in whichever variable we have stored that data vector, we'll just write that name directly. So in place of star one star, we'll write just the ages, because I'm storing all the values in the data vector ages. So I will be writing in place of star one star, I will write ages. Is it fine? Directly we just write the name of the variable. No need to write the table, because in histogram we do not write that thing. Okay. Now just tell me, what should I write in place of star two star? You can just see here the age distribution histogram is the title of this histogram. Yeah, so we should write main. Fine. Now in place of 3, so here I've given X lab to be age. So you can see here it is age. Now in place of 3 star is equals to frequency. So on the y axis, yeah, okay, fine. This will be Y lab. Fine. Now star 4 star is equals to black. What should be there in place of R star 4 star? You can just see the histogram. So what should be in place of star 4 star? So you can see here the color is sky blue. Okay. So it will not be color. Okay. Here the color is sky blue, so it will not be color. But what is black? You just see that the border of the histograms are black. So in place of star 4 star, there is a functionality in this histogram that we can emphasize the border of the bars which we are plotting. So in place of that, we will write border. So that is border is equals to black. So basically it is defining that the borders of the histogram is black. Okay. Now in histogram also we have this option of frequency, that FREQ. So just see that what the y-axis of this histogram is representing. So whether it is representing the frequency or the relative frequency, according to that, tell me that what we should write in place of star F5 star. What should be there? Just see the frequencies of this bar plot and tell me what should be there in place of star 5 star? So in place of FREQ is equals to what can we write? First of all, we had to write the logical variable, that is whether we have to write true or either we have to write false. So when I write FREQ to be true, that means that I am on the y-axis, I want the frequencies to come. But if I write FREQ to be false, means in the y-axis, I want relative frequencies to come. So now just tell me that what should I write in place of star 5 star? You can see in the plot, there are on the y-axis we have relative frequencies because it is less than 1. Each frequency is less than 1. So that is basically the relative frequency. So if I write FREQ to be true, so it will represent the frequency, that is the absolute frequency. But if I write FREQ to be false, then it will give me the answer, or the y-axis. It will give me the relative frequency. So true will not be there. So it will be false basically, because we do not want the frequencies, we want the relative frequencies. So that's why we'll write false. Okay. Now tell me about the color. Sorry, the sky blue. So I have written here star 6 star is equals to sky blue. So you can see the sky blue is the color of the lines. So in place of star 6 star, we will have COL. So color is equals to sky blue. So it will basically is telling me that these lines are sky blue. Okay, just now tell me, I have drawn these lines here. So in this bar plot, these lines are there. So which is the command we use in order to get such kind of lines in the bar plot? In the histogram. So what command do we use inside the histogram to get such kind of lines? Do you remember? So in the histogram, there is a functionality called density. If I write density is equal to something, so it will basically give me this kind of lines. Density is equal to some numeric quantity, which basically tells that what this numeric quantity is telling me that how much how much two lines are separated to each other. Okay, so in place of star 7 star, this we are writing the density. Now I'm getting the clue for this because here in the normal histogram, if I do not emphasize any density, this will be like whole sky blue. But because here I'm getting these lines, so that implies that I have here used something like density. That's why it is coming like this. And also here the angle is like this. By default, the angle comes like this. The lines are like this way. But here it is in this way. So here it is like star 8 star is equals to 140. So it should be the angle. So angle is 140. That's why the lines are coming this way. Okay. So these are the things which are all for this question. So let me just show this first to you in R. So here I have given this data vector to the variable ages and I've plotted this. So see here. I can also show you that if I do not write this density is equals to 7 here, if I do not write it, I just run it without this density. Okay, sorry. No, there is some problem with this. Just give me a minute. Okay, so I was this one. So if I do it directly, then you just see here I've not emphasized any density here and I'm getting this kind of bar plot. Sorry, not the bar plot, it's the histogram. Okay, but if I emphasize here the density, okay, if I emphasize here the density is equals to, for example, 7, then the lines will come. Okay, you just see lines will come. Okay, then apart from this, these the lines are like the direction of the lines are this. Okay, this is kind of a 45-degree it is making. But if I change that, if I change the angle, so basically for that I use this command a angle is equals to, if I do that to be 140, means an obtuse angle I'm making, then the directions or the slope of the line will change. So it became this way. Okay, so these are things I want to emphasize using this question, that how do we basically emphasize that what we want in a bar plot, in a histogram. So is this fine? Is this question fine? Then I'll move towards the next question. Is this question fine? Okay. Okay, fine. So then we'll move towards a pie chart question where we want to construct a pie chart basically. So a data of fruit choice of 20 people. So basically 20 people are asked again to tell that what are their fruit choice. So what is their favorite fruit basically. So data is collected. So this is the data. So this is mango, apple, orange, and banana. Okay. So here it is stored in a data vector called fruit underscore choice. So basically I've stored all this data inside a data vector or inside a variable fruit underscore choice. Okay. Now further I'm asking something, that this is an R command pi star 1 star main is equals to favorite fruit survey, color is equals to star 2 star, labels is equals to star 3 star, clockwise is equals to star 4 star. Okay, then I want that what should be these values star 1 star 2 3 4 such that I get this kind of a pie chart. Just tell me what should be in place of star 1 star. So what is the data vector basically in which data is stored? That is fruit underscore choice. Yeah, yeah, correct. So it will be table fruit underscore choice. Tell me about the second one. So here this is fine. Main is favorite fruit survey. So it is fine. Color is equals to star 2 star. So what should be the colors? So the main thing which here I want to emphasize that there are many colors. Fine. This is red, yellow, orange, and the red, yellow. This is orange, and this is gold color. Okay, so there are 4 colors. Fine. Now just tell me that how should I emphasize the names of the colors? So that is an important thing. From where should I start? But why? See, the thing is like here we have 1, 2, 3, 4 colors. So all the four colors I have to give. But in which order should I give? So basically here I should follow the alphabetic order. So since apple is coming first, so I should give the color red to be here. Okay, and here because after apple, because these things, see this pie chart if I'm drawing, then all the things will be drawn. So for example, if I have these 4 kind of fruit choices, apple, banana, mango, orange, then this pie chart will be drawn in that order only, which is basically the alphabetic order. Okay, so no, the if I'm drawing a pie chart, then it will always be in alphabetic order. It is similar in the bar plot also, because here we are basically concerned with the categorical data. So if I'm concerned with the categorical data, so data which I have, it is basically all I have a strings or characters. So basically I will be following the alphabetic order. Okay, so that's why the first of all the color will be starting from this red. Okay, so it is red, then it is yellow. Until and unless we specify the order, it will be alphabetic. Okay, after that we have this orange. Okay, then we have this color is gold color. So it will be emphasized, it is not like always necessary, just I'm taking the tutorial, I can tell, that's why I have included this gold color. if it is like fully emphasized, then only you have to write. It is not like that you have to always see that which color is there or not. So I've just wanted to show you that in which way you should assign the colors so that it come in this way. Apart from this is labels. So labels are basically what? So labels will give you the values, this apple, banana, mango, orange. Okay, so it should also be alphabetic. Okay, so it is like apple, banana. So these are the labels basically, mango and orange. Fine. Then it is saying clockwise is equals to star 4 star. So clockwise basically it is a logical vector whether it should be true or not. So this is a pie chart. Here I am having this apple. In the right hand side of the apple I am having banana, then mango, then orange. So means I am having alphabetic order in a clockwise manner. Otherwise I can also have in a different reverse order also, no? So I can have this apple or apple, after that banana here, then mango here, then orange here. I can have in this way also, and I can have in this way also. Okay, so if I write clockwise, so here I can see that alphabetic order is in which, so this is the same order I have given. So in this way also, I can have this in this way also. Okay, but here the alphabetic order, if you can see, it is like from, it is in the clockwise direction, because here it is apple, here it is coming red, then it is like a banana, then mango, then orange. So it will be clockwise to be true. So it will be true. Fine? Is it fine? Is this question fine? Anyone? Am I audible to you guys? Yeah, yeah. Alphabetic order is with respect to the fruit name, because whenever I'm giving, for example, if I want to create a pie chart, then I'm giving basically the data vector only. Okay, so when I'm giving the data vector, then for that data vector, basically I want the pie chart. Now pie chart will be in the alphabetic order. Okay, so pie chart will be in alphabetic order. Means, for example, so let me show you here. So for example, I have this data vector fruit choice. Okay, so this data vector I have. Now for example, I'm emphasizing that pie, okay, table fruit choice. Only this thing I'm giving. Then I'm getting this kind of a pie chart. So what is basically happening, that it is like so first the apple is coming, then orange is coming. Sorry, the first apple is coming, then banana is coming, then mango is coming, then orange is coming. So it is alphabetic order in the anti-clockwise direction. Okay, so this is by default it is happening. So basically whenever I will give a colors. So whenever I'm giving this color red, yellow, orange, gold, then in that way, this I can say the order which I'm giving, the red, yellow, orange, gold, means I'm giving red to apple, I'm giving yellow to banana, I'm giving orange to mango, and I'm giving gold to orange. Okay, so red color I am assigning to that category which is at first in alphabetic order. Yellow I am giving to the that category which is second in alphabetic order. Orange I am giving to that category which is third in alphabetic order, and gold is I am giving to the which is fourth in the alphabetic order. So we have nothing to do with the colors, the name, the alphabetic order of the colors. Okay. So this is about this question. Okay, then we move forward for the next question then. Okay, so it is about the scatter plot basically. When I have two data vectors, x and y, then I want to draw a scatter plot basically. Then I have different kind of visualization of a scatter plot. So this is basically about the that how those visualizations are basically changing by changing the commands. So I've discussed, so this is x, y, z, these are the data vectors. Okay, fine. Now here I have this kind of a scatter plot. Okay, so here you can see on the x-axis I have x, on the y-axis I have y. So these are the basically the names of these data vectors x and y. Okay, so when I have to plot or scatter plot basically between two data vectors, then what is the command do we use? So what command should we use to get this is scatter plot? So this is a scatter plot between x and y. So this is a kind of a bivariate scatter plot. Okay, what is the command we use for this? So what is the command we will be using? Bivariate scatter plot. So this is a scatter plot between x and y. So for such kind of scatter plot, basically we use this command plot x comma y. Okay, so this is for the bivariate scatter plot. Okay. Fine. Now this is a scatter plot. Now here these are like kind of a points or kind of bubbles we are creating here. Now apart from this, we have different kind of representations of this scatter plot. By emphasizing here in the code, I can get a different representation. So let me show that those different representations. So this is true by default. But if we emphasize something here in the argument of the plot, I can get different representations. So let me show you. So this is a kind of one representation for the same I can say the scatter plot. So this is a representation. Here you can see that here we had this bubbles, but if we join the bubbles, for example, so if I join it, so it will be like I can join this and this, yes. So I am basically joining this. So I'll just emphasize the type. So what should be the type so that I can get this kind of scatter plot? So this is basically between x and y only. So it is like plot x comma y. This will be the same, and type is L you have typed. So that is correct. So I'll write L in the inverted comma. I can also write type is equals to double commas L. That is also fine, and this is also fine. No problem in that. So I'm getting this kind of scatter plot by using L here. Now, okay, fine. Now if I want this kind of a scatter plot, this is kind of stairs kind of scatter plot. And for that, what should I use? So I'll write plot x comma y. Okay. Now, what type should I use to get this stairs kind of scatter plot? So just remember it by using that S for stairs. Okay. So this is a kind of stairs kind of scatter plot. So we basically emphasize it by using S here. Okay. So here I'm getting a stairs kind of scatter plot. So here I'm emphasizing S. Okay. So these are three kinds of scatter plots which we have done. Now let me come to like more representation of these. This is also a representation here. Here I have the lines. Also I have the bubbles also. So it is also between x and y. So it is like plot x comma y. So what should be the type for this? What should be the type for this? For this kind of scatter plot? Both. Yeah, but for both, what should I write here in this argument? I should write B. Okay. For both of them, I should write B. Yeah, but in the argument, I should write double quotes B. Then only it will come like this, no? I should write plot x comma y, and in the double quotes, I should write B. Okay. So then, so this is, so you can also remember it by using like, first I am doing a scatter plot, simple scatter plot. So then it is coming by default as these circles or these bubbles. Fine. Now when I am doing this L, so when I'm doing this L, then that implies when I'm doing that L means these lines are coming. So that's why I'm using L here. Now if I do this, so this is like stairs kind of thing. So S is coming here. So this way you can remember. Now here in the third one, sorry, in the fourth one, here these bubbles are also there. I can say the small circles are also there and lines are also there. So both are there. So I'll write this B here. Okay. Now this O which you are saying, this O is for the over, when we overlay both of them. So that in that case, this line and the circle will be overlapping each other. In that case, we have this O type. So this is B type, which is we are having both of them, the circles and the lines also. Now just tell me what about this? So what should be the type for this? Plot x comma y. What should be the type for this kind of a scatter plot? So yeah, it is kind of a histogram. So we should use double quotes H here. Okay. So this is kind of a histogram. That's why we are using double quotes H here. Okay. Now moving forward for the next one. Here you can see, here we have the lines and there are gaps in between. So what should I use here? The type. So this is plot x comma y. What should be the type? For this. So basically we use C for this, okay? So this kind of histogram we use C. So here in the lines it was like jointed lines, okay? But here there is a cut between them. So that's why we use C. So there is like, this is kind of a nomenclature, okay? We can just think something about in our mind and we can just use it. So basically it basically provides a cuts between the lines. So you can just remember by using cuts, okay? So this there is a gap between two lines, so we are using C here. So by using C, I can get this kind of a scatter plot. Fine. Now we have another one. So here you can see, here we have the overlapping of this both lines and the circles. So that's why, which you have answered before. So there was no overlapping. Here it is, the overlapping is there. So here we use the command, the type O. Fine. Is it fine? Fine. Now I have two more. You just tell me what will be the command for them. Tell me, what will be the command for them? Here, if you remember that this is a matrix of scatter plot. Yeah, so command will be what? Tell me the command. You know, in order to get such kind of a diagram or such kind of a plot, what should be there? No, see, PAR when we are using, we basically were combining the two plots or three plots or five plots. Okay, here I am constructing matrix of scatter plots basically. Here it is a matrix of scatter plot. So what command should we use to create a matrix of a scatter plot of two scatter plots? So or we can say a bivariate scatter plot. I'm constructing matrix. I have two data vectors. I'm constructing a matrix of scatter plots. So what should be the command for this? So command or the function for this is called pair. We basically use pairs function for this. So it will be pairs cbind x comma y. So this is a command for this kind of matrix of scatter plots. Okay, so here we have two data vectors. Now what if we have three data vectors? So if I have three kind of data vectors, then I can create matrix of scatter plots. So here you can see here this is the scatter plot between so it is x and it is y. So it is the scatter plot between x and y. This is scatter plot between x and z. This is scatter plot between x and y. This is scatter plot between y and z. This is a scatter plot between z and x. This is a scatter plot between z and y, and these are the diagonals. So it is a scatter plot with themselves. So that is nothing. Okay. So what will be the command for this now? So I have shown this for two data vectors. Now what about this? What will be the command? What will be the command for this? So this was for two data vectors, x and y. Now for three data vectors, if I want to create a matrix, just increase the one data vector here. Here only I will write pairs C bind x, y, z. Then it will create a matrix for three data vectors, the matrix of this scatter plot. So it will be pairs C bind x, y, z. Fine. Let me show this to you in R. Okay. So this is x, y, z. These are the three data vectors I've constructed. So let me run it first. Then I'm running that plot x, y. So basically I'm constructing the scatter plot. So this is a bivariate scatter plot between x and y. Okay, now here I'm changing the type. So basically I'm taking L means lines. Okay, so then the lines will come. Fine. If I take S, then stairs kind of structure will come. If I take B, then both of them will come. This both circle and the lines. If I take H, then histogram kind of thing will come. If I take C, means there will be cuts between the lines, so it will come like this. Fine. If I'm taking O, means they will be overlaying. So this kind of thing will be there. The presentation will be there. Now I'm constructing the matrix. So C bind x comma y pairs C bind x comma y if I do. So see here I'm getting the matrix of the scatter plots. Fine. And if I have three data vectors, then I have matrix like 3 cross 3 matrix for of scatter plots. Fine. Now here you can see that how many plots we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 scatter plots we have. So let me show you that how to combine them. So this which we basically use by using this PAR MF row. So what was the command for this? PAR MF row. So yeah, we have done it. So MF row, and we want to create a because there are how many plots? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4. 10 plots we have. So we'll construct a 2 cross 5 array or 5 cross 2 array. Fine. So MF row 2, comma 5. So C2, comma 5 we should write. So now then we are just plotting them. Okay, just this way. I think this was not happening because of this matrix. So matrix cannot be maybe printed. That's why it was not happening. So I've just extruded them And other plots I have shown. So here I have created a 2 cross 5 array. So that means that there are 2 rows and 5 columns. So that's why it is in this way. And each figure, so that is the first plot of the which consists only the this bubbles, then these lines, then this stairs, then this both of them, then there was cuts, and then this overlaying thing. So we have taken all the things and we have taken it in a single plotting area. So is it fine? So the usage, which because you have told about this PAR command, so I'm just emphasizing that what is the difference between this PAR and this pairs when we want to construct a matrix of a scatter plot. Ma'am, what is it? Is it 3D is same as 3 data in a matrix vectors? So what do you mean by it? I'm not able to understand. So 3D, you are telling, so 3D means that you are talking about the three-dimensional image or what? So 3D plot is a different thing. It is not about 3 data in matrix. So 3D plots are different things. So 3D plot and the 3 data in matrix vectors, they are not, I don't think so. Okay, they are the same things. Okay, so this is about these questions. Now, so we have discussed these questions. Now we will be moving towards a construction of functions, basically. So in yeah, 3 data vectors in 2D format. So which command are you talking about? I'm not able to get it. So you are saying that 3 data vectors in 2D. So 3D is where we are using it here in any command or other command you are talking about? Cbind. Okay. You are so cbind here XYZ. So this basically means, okay, you are talking about it. So actually this basically means that we are binding this X, Y, Z. So basically, uh, there is a scatter plot between X and Y. There is a scatter plot between Y and Z. And there is a scatter plot between X and Z. Okay, so there are 3 scatter plots. Okay, so there are scatter plot between, this is a scatter plot between X and Y, for example. There is a scatter plot between Y and Z. There is a scatter plot between uh, X and Z. There are 3 scatter plots. So only the things which we are using by using this command pairs, we are basically arranging these 3 graphs in a 3 cross 3 matrix. Okay, where this is the first one representing the scatter plot between X to itself. Now then it will be nothing because we are finding out the scatter plot between itself, so there will be nothing in place of X. Then this is representing the scatter plot between X and Y. So so here you can see, you can talk about X, Y, Z, X, Y, Z. Here it is between X and X. Here it is between X and Y. Here it is between X and Z. Here it is between Y and X. So this and this is same, but the direction is like reversed. Otherwise, these both the scatter plots are same. Only the directions are different. This Y and Y is this nothing. So Y and Z is here. This Z and X here, Z and Y here, and Z and Z here. So this nothing. So this way it is only, we are just representing the scatter plots between X, Y, and Z. There are 3 possibilities. I'm just taking all these 3 scatter plots and I'm just putting it into a matrix. Matrix of scatter plot I'm just making. So there is nothing called 3-dimensional or something like that. So we are just having a matrix where we are representing 2D plots only. Okay, fine, just let it be. So okay, so we'll move forward for this one. Now, So here in this question, it is saying that construct a function in R that takes four arguments x, y, z, w and returns the value of the following expression. So I want to construct a function which take arguments x, y, z, w, and this kind of expression, that function is returning, so that whenever I take that function in the argument, I write particular values of x, y, z, w, then it will give me the evaluated values, and that what is it coming as the answer for this expression. Okay, so I want to construct that function. Now for that, what I'll do, I'll use that function. So let me take this as a f. So this is f. I'm taking as function of x, y, z, w. Fine. Then in that function, I'm emphasizing, I want to write this expression. Okay, so that is x to the power 3, fine, plus y to the power 3 plus z to the power 3 plus w to the power 3 plus 3 star x star y star z plus 2 star x star w star z. And I'll just close this bracket. Now I want to divide it by this quantity. So by, it is in square root. So SQRT, I can write SQRT of x plus y plus z plus w to the power 2 plus 1. So this will be the expression. Okay, so now we have created a function of x, y, z, w. Okay, fine. This f is a now function of x, y, z, w. Now it will, now if I write anything in the argument, then it will give me that values. Okay, so here if I see here, it is like if I write it directly, okay, and if I write f 1, 2, 3, 4, then it will return me the value when I'm taking this 1 at place of x, 2 at place of y, 3 at place of z, and 4 as place of w. It will give me the value of this expression. Let me show it to you in R. So in R, I have given this command. So here I have constructed in a different way. So here I have directly taken the bias. So that is also fine. Here I have taken it as numerator and denominator. So numerator, I have considered this vector, this the numerator thing, that is x cube, y cube up till w cube plus 3xyz plus 2xyxwz. So in this way, and denominator I have created, and then I have just divided it numerator by denominator. Okay, I have stored this in result, and I have returned result here. So this will give me the same thing. The function which I have written here and the function which I have written here, they both are the same things. Okay. So now if I run this, so now f is basically I'm running only this one. So now this I have created this function f. Now if I want a particular x, y, z, w values and I want to evaluate at those values the expression, the value of that expression is coming. So then I will do that and I'll get the value 26.7889. So that is basically when x, y, z are 2, 3, 4, 5. For x, y, z, w are 2, 3, 4, 5. Then I'm getting this value for this expression. Okay. So this is the way we are creating a function of these four variables basically. So is it fine? I think there is no problem. This function thing which we have already studied in previous classes. So is it fine? Okay, so now what is basically the necessity of such kind of function? So for example, here I can consider that x, y, z, w is a single data vector, okay, which is of length 4. Fine. But the data vector can be a very large quantity, and I want to evaluate a function for example, for 10 variables. This is like only 4 variables. I can also want, can have a function which is of 10 variables, 100 variables. Fine. Then in that case, writing this whole thing here is a very kind of a complicated task. So I cannot, so if in place of this x, y, z, w, if I had, for example, 100 variables and I want to I have a function which is of 100 variables, and I want to just make that function, I want to evaluate that function, then writing that function explicitly in this way will be a very tough task. So for that, how and what should we do, we will be discussing that in a next example. So this is why basically we aim to construct a function of such kind of a variable xyzw which is of length 4. Now if I have a variable of data vector of length 100, then I'll create a single function of that length 100, and I can just put that function in a different function and evaluate the expression. So that I will be discussing in the next example. Fine. So here I have a particular kind of function. So this is basically a function I want to create. Now here you just see that I have this function of x and y, but x and y are itself a data vector. X is a data vector of some length, y is also a data vector of some length. Fine. Now I want to calculate such kind of function which is there in the expression. I want to have this kind of function so that in the argument, if I put the values of x, if I put the values of y, in the argument, that I just so that I can evaluate the value of this expression by only putting the value of the data vector. I want to construct such kind of function. So now explicitly going for, like, for if length is 10 or length is 100, if length is 200, then explicitly going for the each of the value and doing all the things will be a very tough task. So basically here the variables are basically x1, x2, xn, y1, y2, yn. These kind of variables we have. But in place of the variables, I can also see that x is basically a data vector which consists of entry x1, x2 up till xn. And y is again a data vector which consists of entry y1, y2, yn. Okay. Here just for this function, we can just observe that the expression like xi square plus yi divided by under root of mod of xi minus yi plus 1, the summation. Now this thing is common everywhere. This kind of whole function is a function of this function. Summation of xi square plus yi divided by under root of mod of xi minus yi plus 1. And the same expression is here. And the same expression is here. This is same as this expression and this expression and this expression. So in order to construct this function, first of all, let's construct this function. Okay. First of all, we'll just construct this function, assign a particular value to that function. Okay. Then we'll just do further calculation by using that function. So first of all, in place of fxy, let us construct first of all gxy, which is this function. Fine. And since because it is written that I have to use loop, so I will be using loop in order to construct this function. Okay. So basically I have the summation of xi square plus yi. So let us consider first of all construct this function gxy, where x and y are the data vector basically. Okay. So it is function of x comma y. Now how is this, how this function is basically? So it is xi square plus yi. So first of all I'll run the loop for I in 1 to length of x. So of course the length of x and y should be same. Okay. 1 in length of x. Now I is from 1 to length of x. I want xi square plus yi. So I'll just before only I'll write sum to be 0, because now I want to sum the things. So it will be like here sum is equals to sum plus this expression. So what is it? Xi square. So it is xi to the power 2 plus yi plus yi. I'm writing it in the as a location. Okay. And then I have divided by, so this quantity is divided by the square root of, so after division I'm writing sqrt of mod of xi, that is abs is the function for that. So xi plus yi, I think plus 1. Sorry, minus yi we have here. minus yi plus 1. So this, okay, then, so it will be, that's all. Fine. So this will be a function. So what it will do when sum is 0, now I'm constructing a function of x comma y. For I in 1 to length of x, means x is a data vector. So I will be running from 1 to the length of the data vector. Sum is equal to sum plus this quantity. So when I is 1, so it will be x1 square plus y1 divided by square root of absolute of x1 minus y1 plus 1. So it will run for 1. The value of sum will be that. Now when it will be I will be 2, then sum will be that. So it will be like for 1 plus for 2 it will be there. Then again the loop will run. Then the third thing will be getting added. So in this way it will get added, and this will give me this function. Which function? This will give me this function. Fine. This is now my gxy. Now I want to construct this fxy. So now fxy will be, this is again a function of xy. Fine. Now we have gxy here. So it is like log of 1 plus gxy to the power 3 by 7. So I'll just store this in VAL to be equals to gxy, because writing VAL will be a little easy task. That's why I'm storing this gxy inside this VAL. Now I will write VAL everywhere. So it is log 1 plus log of 1 plus VAL to the power 3 by 7 to the power 3 by 7. Okay, then divided by exponential of, so it is divided by exponential of this to the power 3 by 7 divided by 5. VAL to the power 3 by 7, okay, divided by 5. Fine. Now, plus, okay, so this is this quantity plus VL to the power 3 by 7. So this is absolute of VAL to the power 3 by 7. Fine. So this is done. Now this whole quantity is added to this quantity. So that is square root of, that is SQRT of VAL to the power 2 by 5 to the power 2 by 5. Wait, not this. VAL to the power 2 by 5 plus 1. So this way. Yeah. So this will be the expression for x f x y. So whenever you write now in place of data vector x and y, x and y, you just give data vector. It will give you the value of that function. So I have written two different ways to write this function. One is similar to the way I have written here, and one is a little different way. So let me show it to you in R. So here I have written this way. This is the way which I have written here in the slide. So this is that way. So I have assigning sum to be 0. I have taken the function of x, y, and I'm doing the same thing. The same thing I'm doing here, but alternatively also I can do. So I can define the data vectors before only. I just create the function gxy here in the same way. But when I'm creating the function fxy, then I just create a function without an argument, and I'll just give the value v to this gxy, val to gxy, and do the same thing here and written fxy, and then I'll just call this function in this way, f on open parenthesis. The only difference between this function and this function is like when I'm creating this function f, then this function is like without any argument, and we are just specifying the data vector previously. However, for with this code, I'm not specifying any data vector. I'm just constructing two functions, that is g1, and I'm using that g1 in f1, and I'm constructing a function, and I can just write the data vectors inside the arguments of f1 and get the answer. And here previously I'm defining the data vectors and doing the things. So this is the difference. Both are the same things, and I can get the same output for both of them. Let me show you. So here I have this data vector xy, okay, and I'm getting the output 2.872053 for these two data vectors. Now same two data vectors I've used in this function f1, which I've constructed in a different way, and here also I'll get the same output. So in whichever way you want to construct, you will be able to like construct in the same way, unless your logic is fine. So is it fine? Is this question fine? A little expression is there, so it may be a little difficult to get it in this way. But yeah, the main major task for me was like how to differentiate between two codes. So this code and this code both are same. So we can do it in this way, and we can do it in this way also. And there are multiple other ways also by which we can get the same result. Okay. So I think these are the only questions which I've prepared for today. But if you have any like doubts or something like that, then now you can ask. So now the recording for today's session will be uploaded on YouTube for this session, and the PPT and R script I will be providing on the Google Drive. And the deadline of the assignment is 15th of October. So I hope you people submit it by then. Okay. And also, yeah, today is our last live session for this course. And I hope that all of you are getting the things and like perform good in the exam which we will be giving. Okay. So now if you people have any doubt, then you may ask. And you, if you have any doubt regarding today's this questions or something like that, you can ask. Anything about anything here, we have discussed many things today. So you may ask anything. So no doubts, there are no doubts. So exam venue, you have not got any detail about that. So just please post that question there in the like on the portal only, because I will be not be able to answer this question that where when you will be getting this, because the NPTEL team will like arrange it for you. But I hope so. When is the exam? When is your exam? 26th of October. Okay, so I hope, or I think like before 1 week, maybe there is a possibility to get the admit card. I hope. I don't. I'm not sure actually. So it is today is 13th of October. So there are like 13 days more to that. So I hope that like before 1 week or something like that, they will be providing the admit card. Otherwise, you just post that question. So have you posted that there? Yeah, just post that question. Someone will answer that. So you must have registered the for the course for this course, our course. So I think according to me, for any exam, if you are preparing, then just prepare it like just have a kind of a little essence of the subject, in the sense that why we are doing something and how basically so just remember the basic things, and don't like just like think kind of logical things, like if you are so in this course basically remembering the commands or remembering the names of the commands is a little difficult. So just you can have a little focus about that. And I think that there will be questions or like more questions on outputs, because if you are having a command, then what will be the output for that. So in that sense, just thoroughly read the commands, that what are the commands, what is used for what are the differentiation between two commands. Like for example, if I'm using paste and I'm using cat, then what is the difference basically? Why do we use these two commands? And why, what is the difference? What is the need of cat command when there is a paste command? So in that way, just study. I think then it will be fine. The questions in the assignments are really easy. You may be able to solve that. But like if you are yeah, if there is some advanced R software course, then you may join it further, because this is a basic course for R software. It is like basically we're discussing about the fundamentals of R software. So basic things like how do we what are the basic commands to do the things. If you are doing data analysis, if you want an advanced version, then this course is not for that. So for advanced version, if there is some course which is floating, then you may register for that. Like I do not have that knowledge that what course is basically running for this hour. So if there is some course running, then you may take to. I don't think so. See, R is a very vast software, so there are many commands which may not be covered in this 12-week course. So it is always, so if you want to learn something, you cannot be able to learn it fully. Even I cannot also say that I know the R fully. So it is always dependent about how are you practicing it. So if you are using it, okay, you may be able to use some functionalities of it. You may not be able to use everything, because it is about the need of the user. If you want to use it in a certain way, then you will be able to like for example, a bar plot. If you are plotting a bar plot and you are just learning the basic things, okay, how to plot a bar plot, okay, fine. But if someone is doing research, or someone is doing a certain specification or specialization in a particular topic, then he or she may go in depth and know everything about that command or that thing. Here I also can see that many of the commands which have not been discussed, because it is not possible to cover everything in a 12-week course. So it is enough in order to get comfortable with R. Okay, but if you are getting comfortable with R, you can explore it by yourself also. Okay, so it is like a very user, I can say a user specified kind of thing. If you are interested in a certain aspect of R and you want to explore that aspect, so then it will be like you will be able to explore more and more. So it is what your interest is the main thing. So about what you are saying, like except graphical in data science. So see, in data science, if you are talking about data science, the data science is also like very broad, domain. We have various different kinds of data analysis. You are graphically, you are just interpreting the data, and you are seeing from very at the backwards. You are saying, okay, fine, this is the thing I'm observing in the data using the graphical things. Okay, but when you want to do a data analysis, so if you know something about statistics and all those things, so in statistics we have many methods in order to find. So for example, I have an estimation problem. Okay, I want to estimate some parameter of a particular density. I want to simulate. So for example, I do not have a data. I want to create that data first of all, and I also know that what is the true density of that data. If you have no knowledge about statistics, then what is the true distribution, and from that I want to get a data, and I want to analyze that data in a certain way, and I want to know that whether, so for example, I am a research scholar here, and if I want to construct a different methodology for a estimation of a parameter for a probability distribution from the data, then if I'm theoretically for example deriving something, but in a practical sense I want to get insight that particular data, whether my theoretical aspects are getting validated using a data or not, then I will be always be using R. So if, apart from R, I can also use Python. There is no problem. But in R, if I want to generate some data, then in R it will be very easy to generate from a particular distribution. There are directly commands are given, or directly packages are there through which I can call and I can get the data from a particular distribution. So there is vast applicability of R when you are talking about a practical scenario. Here we you have only seen this graphical things, but the graphical things are not that. So it will give you a little insight from very far away that okay, that data is representing something or something like that. But you cannot say that it is it is the final thing. You cannot say that. But when you are developing something theoretically and you want to validate through particular data or something like that, then R will be always be helpful. So it is like that. Or I can, in a layman language, if I say that if you have a mathematical calculation, a very lengthy mathematical calculation, then by hand you will not be solving it. You will always be doing it using a calculator. So similar kind of thing, like if you are doing something and if you want to do that in a very efficient way, then R will always be working as a tool to get the results. So it will be working as tool. More knowledge about what? About R? For what? So for which knowledge you are talking about? Knowledge about R, you are saying? So if you want to get knowledge about R, so so it is always dependent on. So you are doing a course here. You can do also join course, like if someone is teaching, then you can do that. Apart from that, you can explore like by yourself. So it always depends upon what kind of work you are doing. And from the sources, obviously internet is there, you can get the things from there also. um yeah, so actually this R is majorly for the mathematics statistics, majorly I'm talking about. So whenever you are performing statistics and all these things for a data only, so statistics is also all about the data only, from the data whatever we are using. So that is majorly about it. For example, if you have time series data, okay, so for the time series data you have different models, then you can use it. So that is the major concern of R. So that is a major thing for R. So R is basically for that only. In other fields also people use it. Wherever the statistics is used, R is used. Nowadays people use Python also. There is no problem with the Python also. So there are inbuilt packages there also. Yeah. So if there is no more question, then I will be ending this meeting. So I hope you people have a little understanding about the topic in this 12-week course. And I hope that all of you perform well in the exam. All the best, all of you, for the exam. Okay. So, okay. Thank you, all of you. And have a good day. Okay. I'll be ending this meeting now.